Domestic water system sterilization is a procedure to effectively disinfect water mains following large volume system upset. This includes the preparation of water mains, application of chlorine, and sterilization, followed by testing the presence of coliform bacteria. This procedure incorporates industry best practices and guidelines set forth by the ANSI AWWA Standard C651, American Water Works Association, and Water Engineering. Before the actual work begins, it's necessary to begin with a minimum of 3 working days' notice prior to the chlorination procedure. Remember, chlorination should be scheduled to end on a Monday through Thursday in order to coordinate with the lab schedule. Determine the team of professionally trained personnel. Warning signs should be posted at each outlet or point of use to alert people that work is in progress. You have to be prepared for proper disposal of wastewater to avoid harmful effects. Keep your DR900 chlorometer handy to measure chlorine residuals at both high and low range. Order and stock up enough test reagents for chlorine and pH buffers. You don't want to get into a sticky situation. Create log sheets before the procedure begins and note the date, time, location, test result, and reaction to out-of-spec condition. Identify all mains water supplies to the building. Find the dead legs. Do not miss out on them. Make a list of all fixtures to drain, flush, or valve off. It is recommended to remove carbon and all filters from exposure to high chlorine levels. As per ANSI AWWA Standard C651, the acceptable chlorination methods are the continuous feed method and slug method. In continuous feed method, fill the main and flush it with potable water to remove all air, pockets, and particles. Then, refill the main with potable water that has been chlorinated to 25 mg per liter. Now, leave the main for 24 hours. This period is called the holding period. After the holding period is over, there should be a free chlorine residual of not less than 12 mg per liter. In slug method, feed the water that enters the new main with a single dose of chlorine at a constant rate. Do so until the water has concentration not less than 100 mg per liter free chlorine. The chlorine has to be applied continuously to a concentration of about 100 mg per liter for at least 3 hours as it moves through the water main. Now let's begin the process. Preparation for disinfection. Post signs that water cannot be used for showering, drinking, or cooking. Also notify that hand washing and toilet flushing during the hold period must be avoided. Alert clinical areas that water cannot be used for clinical purposes such as dialysis. Okay, now the game begins. Preliminary flushing. Before the main is chlorinated, fill it with potable water to eliminate air pockets. Then flush to get rid of the particles. The flushing velocity of the water in the main should not be less than 3 feet per second, or 0.91 meters per second. Now remove, inspect, and clean flow restrictors or aerators. Remember to keep flow restrictors or aerators off until initial high flush or fixture is complete. Also, check a few shower heads. If there is any particulate in the shower head, remove all of them and clean. Now you have to begin flushing to ensure flow rates before you start injecting chlorine. Seek out any possible leaks and repair it before the sanitation begins. Let's move on to procedure for general supply lines. To begin with, make sure that the system is full of water and under main pressure. Now, use injection equipment on site to inject disinfectant through the service inlet at a slow, even, continuous rate until tests at the farthest outlet show the appropriate chlorine residual concentration. All other outlets should be tested for compliance with the desired residual. The waste chlorinated water must be disposed of properly. Close all outlets and valves, including service valve at main and injection inlet, to retain the chlorinated water. Set up warning signs at each outlet. Remember, this condition must be maintained for the minimum disinfection method contact time. Water engineering will continuously take representative samples to test chlorine and ensure proper residual is maintained during the whole duration of the disinfection process. Mark that if residual drops below minimum required level, the steps 2 through 4 must be repeated. After successfully completing the above test, flush the system until the chlorine residual is 0.5 ppm or equivalent to that of the initial water supply. Next up, procedure for hot water heater disinfection. Start off by injecting chlorine or bleach downstream of hot water master mixing valve, and if master mixing valve is not installed, then add approximately 50 ppm free chlorine. This will ensure that a minimum of 25 ppm free chlorine will remain after 2 hours of contact time. Now, open the hot water storage tank or the heater and drain with full flow until it gets clear. Next, open the hot water return pump hose bib, if it's there, and flush to drain at full velocity for at least 3 minutes and make sure it's completely clear. If possible, lower the hot water heater temperature to approximately 110 degrees Fahrenheit. The last step, open up the hot water tank drains and the hot water return pump hose bib once again in the middle of chlorination and flush again. Safety is the key here. Make sure you have all safety equipment ready. Now, let's move on to the next process. Fixture disinfection. In patient-occupied areas, follow this procedure without any deviation. Remember to close the bathroom door prior to flushing. If shower hose is used, then lower the shower head to minimize aerosol. Now, cover all faucets with rags. This will minimize aerosol spread and mess created due to the removal of flow restrictor. Flush each sink, shower, hose bib, ice machine at highest possible flow until approximately 50 ppm free chlorine is detected. When possible, flush all fixtures on the same riser at the same time. In case patient bathrooms are back-to-back and sinks and showers are on the same drop leg, then open all the bathroom fixtures which are back-to-back at the same time to increase velocity on that riser and drop leg. If showers have diverter valve which supplies water to shower head and shower hose, then ensure both shower head and shower hose are flushed properly. In case the water is turbid, then continue flushing until water is completely clear. Make sure to keep the flow restrictors or aerators off until initial high flush of fixture is completed and water is clear. Now, reinstall the flow restrictors and aerators and continue flushing until approximately 50 ppm free chlorine is detected. Use blue painter's tape on door lintel. It will help identify the rooms which have been already flushed. Make a note on the log sheet for any fixture having significant issues. It can either be poor flow or more discoloration than others. Once the last fixture in the building has been flushed, turn off chlorine and begin the countdown. After disinfection is completed, replace all water filters. Oh yes, don't forget to disinfect all the ice machines as well. Final flushing to remove high levels of chlorine. Make sure to complete final flushing between 9 a.m. on Monday and 3 p.m. on Thursday in order to expedite laboratory analysis. Ensure adequate drainage during flushing of water. If applicable, the valve isolation, the main, from the system should be locked and tagged. This will help prevent unintentional or accidental release of the chlorinated residual water used for disinfection. Flush any cross connections between mains that typically have a low flow. Utmost consideration should be given to the impact of highly chlorinated water flushed into the environment. In order to reduce the detrimental effects to the ecosystem, an adequate amount of reducing agent should be applied to the chlorinated water before disposal. Neutralization of residual chlorine is mandatory. Now, the most crucial part, as nobody can escape a test, our process needs to go through it too. Bacteriological testing. Once the final flushing is carried out, representative water samples are taken for chromogenic substrate testing, detection of coliform bacteria. If the test result indicate that E. coli is absent in 100 milliliter sample, it means process was successful. The test requires 24 hours to complete, thus occupancy and/or clearance approval will be issued only after this period. On the other hand, If coliform is found to be present, the disinfection procedure has to be repeated until the standards are met. Sampling and analyzing for other substrates will be required as when needed by client. Once satisfactory results of water test are confirmed, provide a verbal notification of approval to the client, which is to be followed by a written report. Unsatisfactory results has to be notified to the client verbally, with a written follow-up, as necessary. In that case, the disinfection has to be repeated until the standards are met. With this, we've come to the end of the session. Water Engineering Inc. has been in the forefront of a positive change with respect to saving the environment with its eco-friendly methodologies and high safety standards. Our aim is to manage water for the future, and thanks for being part of it.